Okay, so last time we did several examples on cylindrical coordinates. Now we'll continue with a last section, which is absolute dependent motion analysis of two particles. In this section, we'll try to relate motion of bodies connected to each other through a system of pulleys. So the concept in such problems is the following. Whenever you see a system of pulleys and objects connected through the system, you should identify what is the number of chords you have. You should you should select for coordinates needed to describe motion of your system, and you should write the total length of your chords function of these coordinates. Once you do this, you derive the relations to relate velocities and accelerations. So let us take first a simple example, and then we'll go to more complex cases. So the motion of one particle can depend on the corresponding motion of another particle. For example, in the following figure, motion of A downward. So if you take the following simple system, you have one pulley connecting two objects, body A and body B. So as A will move down here, B will go upward. Okay, and we can really, in a simple way, without any calculation, say that velocity of A in a magnitude is equal to velocity of B. But for more complex cases, it's not easy to relate directly the velocities and acceleration. So we need to develop a technique allowing us to relate velocities of your blocks and acceleration of your blocks. To do this, you say first, how many coordinates I need to describe motion of my blocks? First, A is moving along this direction, okay? So I need a coordinate for A. And always, whenever I set a coordinate, I need a certain reference line. So here, for example, I should select a fixed line on my figure. So for example, this pulley is fixed here. Its center is fixed. So I can take a reference line passing by the center of this pulley, and the coordinate SA will be along the motion of A. So since A is moving on the incline, I take the coordinate of A like this. So SA will represent the position of A at any instant of time. Now block B is moving in another direction of A. It's moving along this direction. So same procedure, I need a coordinate for B. So I take a reference line passing by a fixed point, and this reference line should be perpendicular, if you want, to my coordinate of displacement. So here, this is my coordinate of displacement, and I will call it S of B. Once I put my coordinates SA and SB, and I want to relate the velocities of the two blocks, the next step will be to express the total length of my chord function of these coordinates. So if you look at your system, okay, this is my chord. It's constituted by three parts. Part one, the arc of circle CD, and part three, okay? Now, because I considered this distance to be S of B, so part one is equal in length to, so L1 is equal to SB. Now, the second part of my chord is arc CD. So L2 is equal to length of arc CD. And finally, the third part of my chord is L3 equals to this distance, which is S of A. So L3 is equal to S of A. And now I can say, since the total length of my chord is a constant, because this is not a spring, it's not elastic, the length will not change. And keep in mind, a cable cannot sustain compression. It can only sustain tension forces. So this cable is in tension, and the total length of my chord, which is a constant, is equal to the summation of L1 plus L2 plus L3. So SA plus length of CD plus SP. And now, if you derive this relation with respect to time, what do you get? When you derive with respect to time, each constant derivative is 0. And when you derive SA by dt, this represents the velocity of A. dsB by dt represents the velocity of B. So you have that VA plus VB is equal to 0. So VB is equal to minus VA. And then once you get a relation between the velocities of your two blocks, you can derive again with respect to time. So you derive another time with respect to t, and you say that AB is equal to minus AA. Okay, now how to do the interpretation of the negative sign? Why I have opposite velocities and opposite acceleration? Because keep in mind that your coordinate is positive downward, okay? And as expected, if A will move down, B will go up. So according to the positive coordinates direction, VA and VB will be of opposite side. Okay, this is why we got the minus here. Any question on this part? Okay, let us do more complex examples on this. If you consider the following system of pulleys and you have two blocks A and B connected to the system, you have the following. You have the first step in any problem like this is to determine how many coordinates I need to describe the motion of my system. First, I have a block A that is moving horizontally. So I can take a horizontal coordinate for A, and I should take a reference line passing by a fixed point. If you look at the pulley here, let me zoom it a little bit, 1 second.
بس دكتور who told us إنه ال A is moving to the right?
نعم.
Who told us إنه
مش ضروري تكون moving to the right.
ممكن
It can move to the left. Look, it can move to the left and then your velocity will be negative. When you set a coordinate, okay, مش يعني إجباري A is moving like this. It can move in the opposite direction and then your velocity will be negative.
It will be negative. I thought you said it's moving to the right.
No, it's moving on the, yes. I said it's moving horizontally, okay?
Yes.
It's moving horizontally, but it can move to the right, it can move to the left. Here, if I do an analysis, it will move to the left because B, under the weight of B will move down under the effect of its weight, and then A will go in this direction. Okay, so in this case, when you solve for VA, you get a negative result. But why we take the coordinate like this? Because we'll consider here a fixed reference passing by the center of this pulley. The center of this pulley is fixed. Okay, so since my motion is horizontal, I can take the reference line vertical passing by this point, which is fixed. So this is my reference line. Okay, this is my reference line. And the coordinate for block A, I can take it from the reference line to A. So this is S of A. Now, since A is moving in the negative direction, then I expect that VA will be negative. Okay. Now, what are the other coordinates I need? For a pulley, to know if a pulley is doing translation or not, you look at its center. This pulley center is attached to the ceiling level, so it's not moving. However, for this pulley here, or this one, the center of this pulley is attached to block B. So this means what? The center of the pulley and the block B will translate together. So the velocity of this point here is equal to the velocity of block B. This is why we don't need one coordinate for this pulley and one coordinate for block B. We can use one coordinate for both because they are moving together. So this is why your second coordinate, you have two possibilities. You can take it towards the center of the pulley, or also you can take it towards the block. It doesn't matter because the difference between these two coordinates is a constant h. And whenever I derive, any constant will cancel out. Okay. So, so here I can say that I need two coordinates, S of B and S of A. Now, second step, I will find the total length of my cord. Okay, I have first, I'm starting from this point. This distance is SA. Then, when I move from this point to this one, this is a fixed distance, okay? Because I'm moving from a fixed point to another fixed point. So this is a constant h. Now, all these arc of circles have constant lengths. So I can lump all of these arc of circles in one constant. Plus, concerning SB, I selected the reference line here. I consider that the reference line is passing by the center of this pulley since this point is fixed. This selection will allow me to say then that when I move through this distance, I'm moving a distance equal to S of B. And this part is a constant, this arc of circle here. Now, if I go up, I'm moving again SB. So this is SB plus SB, which will give me 2SB. And this part here, the final part, I can call it H prime. It's a constant, okay? So all constants can be lumped together. So as you can see, they are in red here. These parts are constant, this one, and the arc of circles here are constant length parts. They are not varying. This is why if I write the total length of my cord, it is SA plus H plus the constant, if you want, of all the red lines, plus 2 times SB equals to the total length. And you can lump now all constants, which are H, the red lines, and the total length together to say that 2SB plus SA is equal to a constant. And then you can derive this relation the first time with respect to T to get 2VB plus VA equals to 0. And if you derive another time, you get 2AB plus AA also equal to 0. And then you were able to relate velocities of your blocks A and B and acceleration of your blocks A and B. And as expected, they have opposite sign. So when B is moving down in the positive direction, because SB is considered positive downward, A will move to the left. So it will have a negative velocity. Okay. Any question on this? Okay, so let us do some examples together to see how to apply these concepts. Let us consider the following figure. We have to determine the speed of block A, knowing that block B has an upward speed of 2 meters per second. So In this problem, as usual, the first step is to determine how many coordinates I need. Okay, I will start from my block A. My block A is moving, okay, so in the vertical direction. So I will take a vertical coordinate and I will select a certain reference line. I have several choices for my reference line. You can put it wherever you want, okay? I can put it at the ceiling. I can put it passing by this point because this point is the center of a pulley that is attached to ceiling, so it's fixed. So you are free to do what you want. At the end, all constants will cancel out. Okay. So here a good choice will be to take the reference passing by the center of this pulley. And then this part of the chord will be equal to S of A. Okay. So my first coordinate needed is S of A. Now, for each pulley, you should check if it needs a coordinate or not. This pulley center is attached to the ceiling, so it's not translating. I don't need a coordinate for it. Pulley C, if you look at pulley C, the center of C is attached to the periphery of pulley D. So C, okay, will be moving because D also is moving. Why D is moving? Why D is translating? Because this point is attached to a moving block. So both pulleys C and D have centers undergoing translation. So I need a coordinate for of position for pulley C, and I need a coordinate of position for pulley D. Now, D and B will translate together. And this point and block B will have same velocity because they are related through a small segment of constant length. Okay. So no need to have one coordinate for B, one for D, since they have same velocity and same acceleration. This is why I say I will take for the center of pulley C a coordinate, S of C. And I need for or D or B one coordinate. In general, when the block and the pulley are moving together, you can take the coordinate to the center of the pulley. So this will represent motion of B. So you can call it SB or SD. This is your first step. Once you are done with setting the coordinates of your system, you can move to next step. Next step is to identify how much chords you have and to write their total lengths function of your position variables SA, SB, and SC. So let us start to follow the first chord. The first chord is starting from A, it's going up, it's turning around here, then going down, then turning around C, then going up to the ceiling. So this is my first chord, okay? I have here two chords. The second one will start from the center of C. It will go through the periphery of D, and then will move up to the ceiling level. So this is my second chord. Now let us express the total length of each of my chords. To start with, let us start with chord A. The first part of chord A is of length SA, okay? All constants, I will lump them in one value. So this is a constant part. Now, when I move from this point to this one, can you tell me what is this length here? What is this part?
It's XC minus XA.
Look, XC minus XA is this. But you are going from this level to this one. So this is S of?
S of C.
Yes, it's S of C. So this part is S of C. Now, this is a constant. Now, again, when I go from this point to this one, I'm doing S of C again. And finally, from this point to the ceiling, I have a constant part. Okay, so what is in total the expression I can use for my first chord? I have SA plus 2 times SC equals to a constant. Okay, so I lumped all constants in one term. Now, I move to my second chord. Okay, if I go to my second chord, the first part is this one. What is this length here? Between this point and this one.
This is SB minus SC.
Yes, this is the difference between S of B and S of C. Okay, so this distance is SB minus SC. The yellow color is clear, or you prefer that I change it?
That's fine.
Okay, this part here is a constant, so I lump it with constants. And then as I move from this point to the to this reference line, what is the distance I'm moving? Look, I will erase because it's a little bit confusing now. So we said that this part is SB minus SC. This part is a constant. This part is what? This length. It's S of B.
SB.
Yeah. And finally, this is a constant. So for my second chord, what is my expression? 2SB minus SC equals to a constant. And now I can derive the two relations I got. Okay, so let us derive the two relations we got with respect to time. So as you can see, these are the two relations. Okay, you have, when you derive them, the first relation you get is VA plus 2VC equals to 0. Now, if you derive the second relation, you get 2VB minus VC equals to 0. In this problem, they gave you the velocity of B. They told you that the block B is moving upward with a velocity of 2 meters per second. So since your block B is moving up, if you go back to your figure, okay, since your coordinate for SB is downward, then V, the algebraic value of VB, is negative. So if you replace in this relation, okay, you have three velocities, VA, VC, and VB. Since you have an information on VB and you want to get VA, you can eliminate VC between the two equations, because from the second equation, okay, from the second equation, you can write that VC is equal to 2VB. And then if you replace VC in equation 1, so this is equation 1, this is 2. 2 will give me that VC equals to 2VB. And now, if I replace in equation 1, I will get that VA plus 4VB is equal to 0. And then we can write that V of A is equal to minus 4 V of B. And since B is moving upward, so it has a negative velocity, I will replace VB by minus 2. So VA will be minus 4 times minus 2. It will be equal to plus 8 meters per second. This means that block A will move upward with a velocity of 2 meters per second, while block A will move downward with a velocity of 8 meters per second. Any question on this problem? Okay. Let us do another example. We have another system of pulleys related together, and we want to determine the speeds with which block B will rise if the end of cord A is pulled down with a speed of 2 meters per second. So if I look at this problem, I have 3 pulleys, a block at B, and my hand is pushing point A. Okay, since
But,
my hand, yeah,
Doctor, before you continue, can you please zoom in بس a little bit?
yeah, 1 second. It's fine like this?
Yes, it's much better.
Okay. So in this system, okay, we have 3 pulleys, E, C, and D, and we have a block B. In addition, we have our hand at A pulling the cable downward. So first, since we have motion at A, so we need a coordinate for motion of A. So I need to select a reference line. As usual, the reference line should be a fixed line. I can take it at the ceiling level, or also a good selection is to take it passing by the center of this pulley, because this pulley is at the center of this pulley is attached to the ceiling. So I can take the reference line here. So once I selected my reference line, I say that for point A, I need 1 coordinate to follow its motion. Pulley C, for pulley C, the center of pulley C is attached to the periphery of pulley D. And you know that this pulley is rotating. So whenever you have the center of a pulley attached to the periphery of another, then C will be moving. This center will be translating. This is why I need a coordinate for pulley C. So I will consider, since C is moving vertically, I can take the same reference horizontal line and consider a second coordinate for C. So this is S of C. Now, for pulley E, if I observe pulley E and I look at its center, the center of E is attached to the periphery of pulley D. So I also have a translation of the center of E. This is why I need a coordinate for this pulley. And since the center of the pulley is attached to block B, B and E will move together. So no need to take another coordinate for B, because these 2 points will have same velocity and same acceleration. Okay, so then I just need to consider a coordinate for the center of pulley E, and I can call it or SE or SP. Okay.
بس دكتور
Yeah.
إذا
Yes.
هي اتاتش السند تبعها اتاتش للبول اللي فوق
نعم.
هتعمل روتيت، بس ليش لا تتحرك كترانسليشن؟
لأنه أنت إذا عملت هيدي روتيشن، وقتها البولي تعمل روتيشن، هيدا الكيبل تخيلوا بضل مش بغير لانكس، هيدي البارت مش بتغير لانكس. أنت بس تبرم هالبولي، يعني في part of the cable عم بتروح من هون وعم تنزل هون. So this length is changing, and if this length is changing, E will move. يعني لما البولي, when this pulley will rotate clockwise, E will move downward. If this pulley rotates counterclockwise, لأنه الكيبل بيبرم على البولي صح؟ So if it's rotating counterclockwise, شو بيصير بE? It will move upward. Okay?
اوكي.
There is no slipping between the cords and the cables. يعني بس تبرم البولي إجباري الكيبل إذا بدك يبرم by the same amount يعني of the arc of the rotation. يعني if you rotate an angle theta, your cable will move by a distance equal to r theta. Okay.
Okay.
Any other question on the selection of coordinates?
Yes, Doctor. C, it looks like C and E are also connected. Do we consider the distance between them as S of B minus SC?
SC and C and D are connected
E
together.
and E and E.
Ah, yeah. No need to take another coordinate here because this distance is function of these two. This distance is S of B minus S of C. Okay.
But we consider it in our calculations.
Of course, of course.
Yes.
It's a variable length, but it doesn't require an additional coordinate because it's
Yes.
function of two other coordinates in your graph.
Thank you.
Other questions? Okay. So now, once this step is done, next step to determine how many chords do I have in my problem. Let me follow my chords. So first, I have, 1 second. Okay, let me select a color for the first chord. The first chord, it's starting from A. It's moving up. This is a constant part. Then it's moving down. This is another constant part. Then it's moving up this distance. And finally, this is a constant point. So this is my first chord, okay? If I want to express the total length of this chord, I say part 1 here is joining A to C, okay? So how can I express this length here? What is this distance between these two levels?
A minus SC.
Very good. It's S of A minus S of C. Please, guys, here the figure is misleading. Some people might say A and E are on the same level, so I can take SB minus SC. It's wrong. You know why? Because if your hand will move a little bit downward, E will move up, and then they will not be on the same level. So always look, I'm going from which point to which one? I'm going from A to the level of C. So this is SA minus SC. Now, this length here, this part is between C and E. So what is this length now, this part here?
SB minus S.
Exactly. This part is the difference between this length, which is S of B, minus this part, which is S of C. So I can say that this is S of B minus S of C. And finally, I lump all constants together. So I get in total, okay, I still have this part. So let me clear it a little bit. We said that this is SA minus SC. This is a constant. This part is SB minus SC. This is a constant. And finally, when I go from this point to this one, this is S of B. And this is a constant part. Okay. So what is my total length now? If I sum these three parts, I get that SA. How many times I have SB? 1, 2. So plus 2 SB. And I have minus SC minus SC. So minus 2 SC equals to constant. So this is my relation number 1 that I got from the first chord. Okay. Now, next step is to determine what is my second chord, and I should express its total length also, function of the coordinates I have. The second chord is here. It's starting from this level here until this point. This height, this length here is equal to S of C minus this part. But what is this part? It's a constant. I can call it H. Okay. And since it's a constant, I can lump it with other variables, with other constants into one value. So I can say that this distance can be represented by S of C. Okay. This is a constant. And finally, this part is equal to what? It is SB minus also a constant. So I can represent it by SB and lump all constant together to say that for the second chord, I just have SC plus SB equal